The next two letters stand for extending and replacing. You can buy fully assembled SPEs, but you also can extend them, remove FPGA boards, replace them, or mix them if you want. Mix Altera with Xilinx or different families like Vertex 4 and 5. Ride the FPGA wave, but why not using what you already purchased? The system is extremely flexible by keeping the racer's guarantee. A self-test indicates you if and what went wrong during the process of hardware modification. We offer the fastest system prototyping emulator hardware in the industry. Why? Okay, let's go down to the physics. Delays between FPGAs using switch routing techniques heavily depend on the capacity of the wires and the crosstalk. The capacity has a direct impact on the slope of the signals. You can't use buffers because they are too slow. If you use quick switches, the slope of the signal increases at each switch, depending on the capacity, and so does the overall delay. The capacity of the wire depends on the length of the wire. So the length of the wire and the number of switches are extremely important for high-speed applications. If n is the number of FPGAs, we only use n-1 switches between worst-case distances, and we only have 3.5 centimeters between FPGAs and switches and 2 centimeters between switches. There is not much room left to optimize this switch routing concept. You can also replace switch routing boards with fixed routing boards to speed up the system even more. The crosstalk on the other side depends on the signal density of the 1200 signals between FPGAs. We have a pretty wide area, about 10 cm by 10 cm, where the signals are routed. If you route them through a single PCB, you have to add a lot of ground to reduce noise and crosstalk. Let's talk about the cooling of the system. You might wonder, if FPGAs are placed on top of each other with a distance of 2 cm, don't they heat up each other? Well, this problem is solved quite superb. The fan on top of each FPGA, the switch routing boards and some other metal stripes create an air channel with a controlled airflow from two corners of each FPGA board to the opposite corners. Two fans on the baseboard suck in the air below the plastic plate and blow the air up through the holes in the corner of the FPGA boards. Metal stripes create a fully closed air channel. The two other fans on the baseboard create an opposite airflow and release the airflow below the plastic plate again. A metal stick takes care that the two airflows below the plastic plate are not mixed directly. At the end we have a seamlessly integrated, fully closed air channel system with, for example, 8 temperature controlled fans for 4 FPGAs. Don't worry, it's cool and silent. The case is a very flexible alubox. The height can be changed and can be adapted to the number of FPGA boards. The stripes on each side can be removed and can be replaced by ASP holder stripes. The application-specific boards are then very stable connected to the system. The license-free software SPE control handles various flow issues. It reads the system configuration and creates a board description file which can be used for partitioning tools. Or the top level is read and the switches are set accordingly. The software also takes care of downloading the bitstream and the switch setting configuration. If the baseboard holds the integrated logic analyzer, SPE control sets the trigger states and reads the VCD file. Let's talk about the customer service. It is EDAptability's philosophy that the hardware should be adapted to the customer design and not vice versa. Customers sometimes spend a lot of time and money just to make the design work on a very restricted hardware. Often the overall system performance suffers and the verification benefit becomes questionable. So for each customer design, the application-specific boards can be modified or new application-specific boards can be generated. The FPGA boards themselves can also be modified for customer needs. EDAptability offers a free of charge customer service unless the modifications become too complex. For example, memory application-specific boards are adapted to customer needs in general. The process of modification can be done standalone by EDAptability or with a direct cooperation with the customer. Even schematic exchange of the FPGA boards has been done so far. It all depends on the customer case and its engagement. In the end, we would like to thank you again for your time. We hope you liked the presentation and you would like to know more about EDAptability's system prototyping emulator hardware. We would be very happy about any kind of feedback, and please drop us an email to feedback@edaptability.com. So thanks again, have a good day and goodbye.